Hey everyone, welcome back to our channel. Today, we're diving into the fascinating world of space exploration with a very special focus on what will happen to Voyager and other spacecraft as they journey deeper into the far future. If you've ever wondered how long these incredible machines will keep going and what their ultimate fate might be, you're in for a treat. Make sure to stick around till the end for some mind-blowing facts. Let's get started. The Voyager missions, launched by NASA in 1977, were designed to study the outer planets, but they've far surpassed their original mission. Both Voyager 1 and Voyager 2 have entered interstellar space, making them the most distant human-made objects from Earth. As they travel, they continue to send back valuable data about the environment outside our solar system. But what will happen as they move even farther? Well, their instruments will eventually lose power, which is estimated to occur around 2025. After that, they will continue to drift in space, silent but still intact, potentially for billions of years. Every spacecraft, including Voyager, has a limited power supply. The Voyagers are powered by radioisotope thermoelectric generators, RHGs, which convert heat from decaying radioactive material into electricity. Over time, these power sources weaken. While Voyager has been incredibly efficient, it will eventually stop functioning as its power output declines. Once power is lost, communication with Earth will cease, but the spacecraft will continue its silent voyage through the cosmos, possibly for eternity. Their trajectory could take them close to distant stars, but the vastness of space makes encounters extremely unlikely. Each Voyager spacecraft carries a golden record, a time capsule intended for any potential extraterrestrial life that may one day encounter it. The record contains sounds and images representing life on Earth, including greetings in 55 languages, music, and natural sounds like waves and birdsong. As the Voyagers venture further from our solar system, these records serve as a lasting message from humanity. Even if they never encounter alien civilizations, they symbolize human curiosity and the desire to connect with the universe. These records could survive for billions of years, potentially outlasting humanity itself. While Voyager 1 and 2 are the most famous examples of deep space exploration, many other spacecraft will follow in their footsteps. Missions like the Parker Solar Probe and the James Webb Space Telescope are pushing the boundaries of what we can observe and explore. But the big question remains, will future missions outlast the Voyagers? Advances in technology might allow us to create spacecraft that can last longer, travel farther, and gather even more data. However, the sheer scale of space travel means it could take thousands or millions of years before these craft reach the same distances the Voyagers have already covered. When spacecraft like Voyager finally lose power and communication, they enter what's often called a cosmic graveyard. These spacecraft will continue drifting through space indefinitely. With no atmosphere or external forces to corrode or damage them, they can survive for eons, frozen in time. They won't decay like objects on Earth, but will simply float, potentially encountering distant stars or galaxies after millions or even billions of years. In essence, these spacecraft become cosmic relics, a testament to human ingenuity and our quest to explore the unknown. As we look toward the future, the next generation of interstellar probes is already being conceptualized. Concepts like Breakthrough Starshot propose using light sails to send tiny probes to nearby star systems at a fraction of the speed of light. These probes would be much faster than Voyager, potentially reaching Alpha Centauri within decades. With technologies like laser propulsion, spacecraft could cover distances that would have taken thousands of years. However, challenges such as communication over such vast distances and the durability of these crafts still remain. Future probes could carry more sophisticated instruments and cameras, opening up new possibilities for exploring distant star systems. Unlike Voyager, many spacecraft face conditions that lead to their decay. Satellites in Earth's orbit, for example, can be affected by the Earth's atmosphere, which, even at high altitudes, can cause drag and eventually lead to their re-entry and destruction. In deeper space, solar radiation, micrometeoroid impacts, and cosmic rays can slowly erode spacecraft materials over time. However, the vast emptiness of space means that for spacecraft like Voyager, there is very little to wear them down, allowing them to remain relatively intact for billions of years after losing power. One of the key forces acting on spacecraft over the long term is gravity. When Voyager and similar spacecraft leave the solar system, they are no longer under the gravitational influence of our Sun. However, as they travel deeper into space, they could encounter the gravitational pull of other celestial bodies. For example, Voyager 1 is headed toward the star Gliese 445, which it will pass within 1.6 light-years of in about 40,000 years. While it won't be close enough for significant gravitational interaction, the path of a spacecraft can change over millions of years as it passes through different gravitational fields. Cosmic rays are high-energy particles that travel through space at nearly the speed of light, bombarding everything in their path. These rays can be hazardous to both humans and machines. Over time, cosmic rays can damage spacecraft electronics, degrade materials, and cause malfunctions. While Voyager's systems have been built to withstand radiation, long-term exposure could affect the craft's integrity. Fortunately, once a spacecraft like Voyager is powered down, the lack of operational electronics means there's little for cosmic rays to damage, allowing it to continue drifting through space, untouched by time or energy. In the far future, human space exploration may evolve to the point where we can travel much faster than current technology allows. If we ever develop spacecraft capable of traveling at a significant fraction of the speed of light, we could theoretically catch up to Voyager and other probes. Such missions could involve retrieving these historical artifacts or simply studying them to understand how they survived the harsh conditions of space. However, given the incredible distances involved, catching up to Voyager would be a monumental feat, requiring technology that doesn't yet exist. One interesting concept in future space exploration is the idea of starship graveyards or cosmic repositories. As we continue to send more spacecraft into space, there's a growing interest in creating designated areas in space where decommissioned or non-functional spacecraft could be gathered. This would prevent space debris from accumulating in dangerous orbits or causing potential collisions. In the distant future, humanity might create starship graveyards in remote regions of the solar system or even beyond, where spacecraft like Voyager could be preserved as relics of our early exploration. One of the most exciting possibilities for Voyager's future is the chance that it could be discovered by an extraterrestrial civilization. Although the odds are astronomically low due to the vastness of space, the idea that an alien race might find Voyager and learn about Earth from its golden record is an intriguing thought. If an advanced species were to intercept the spacecraft, they would find a carefully crafted message from humanity, including greetings, music, and images of life on Earth. Whether or not they could interpret these messages remains an open question. NASA's Voyager program was just the beginning of humanity's journey into deep space. Today, agencies like NASA, the European Space Agency, ESA, and private companies like SpaceX are pushing the boundaries of space exploration. Future missions may build on the lessons learned from Voyager, using new technologies to explore even further. NASA's upcoming missions, such as the Europa Clipper and the Mars Sample Return, aim to expand our understanding of our solar system, while more ambitious projects like the Interstellar Probe could one day follow in Voyager's footsteps into interstellar space. One of Voyager's most significant contributions to science is its long-term data collection. The spacecraft has been sending back information about the environment beyond our solar system for decades, giving scientists insights into the nature of interstellar space. This data has helped us understand the heliosphere, cosmic rays, and the boundary between our solar system and interstellar space. As more spacecraft venture into deep space, long-term data collection will continue to be crucial for understanding the universe. These missions could provide key insights into phenomena like dark matter, cosmic radiation, and the structure of the galaxy. Voyager is still communicating with Earth, but its time is running out. As its power source continues to weaken, NASA engineers have been shutting down non-essential systems to conserve energy. However, by 2025, it's expected that both Voyager 1 and 2 will lose the ability to send signals back to Earth. This will mark the end of an incredible era in space exploration, but even after communication ceases, the spacecraft will continue their journey. Without power, they'll drift silently, carrying the golden records and their legacy into the unknown. After Voyager, space agencies have continued to evolve their probe designs to be more efficient, durable, and capable of deeper exploration. The Parker Solar Probe, for example, is currently studying the Sun at unprecedented proximity, while missions like New Horizons have explored Pluto and beyond. In the coming years, newer probes may be designed to last even longer than Voyager, with improved power sources and communication systems. The development of nuclear-powered spacecraft, for instance, could revolutionize deep space exploration, allowing for missions that could outlast even the Voyager twins. While Voyager is technically on a journey toward another star, it will take an incredible amount of time to get there. Voyager 1 is traveling at about 17 kilometers per second, but even at that speed, it would take over 40,000 years to get close to another star system. The immense distances between stars mean that, despite its speed, Voyager is unlikely to reach another system within a time frame that we would consider meaningful. This emphasizes just how vast and empty space truly is, even for the fastest human-made objects. Voyager's incredible journey has not only captured the attention of scientists, but also inspired people around the world. Its mission has been referenced in countless books, movies, and television shows, including the famous Star Trek series, where a fictionalized version of Voyager is discovered by future civilizations. The real Voyager mission symbolizes humanity's curiosity and desire to explore the unknown, and it continues to inspire new generations of scientists, engineers, and dreamers. When we look back at the Voyager mission, it stands as one of the greatest achievements in human history. Launched in the 1970s, Voyager has outlasted its expected mission duration by decades, sending back invaluable data about our solar system and beyond. As it drifts into interstellar space, it becomes more than just a machine. It's a symbol of our desire to explore, learn, and connect with the cosmos. In the far future, long after we've lost contact with Voyager, its legacy will continue, reminding us of the incredible things humanity can accomplish. As spacecraft venture deeper into space, communication delays will become too long to manage real-time operations from Earth. This is where artificial intelligence, AI, will play a critical role. AI systems can allow spacecraft to make decisions autonomously, adjusting their courses, maintaining systems, and even conducting scientific experiments without human intervention. Future missions may rely heavily on AI to explore distant planets, moons, and star systems where it could take hours, days, or even years to receive instructions from Earth. One of Voyager's most significant contributions has been its data on interstellar space. When Voyager 1 crossed the heliopause in 2012, and Voyager 2 followed in 2018, they provided humanity's first direct measurements of the space beyond the Sun's influence. These observations have revealed much about the environment between stars, including the presence of cosmic rays, interstellar plasma, and the structure of the galactic magnetic field. This data is crucial for future missions that plan to explore even deeper into interstellar space, helping scientists prepare for what lies ahead. Astrobiology, the study of life in the universe, is becoming increasingly important in deep space missions. As spacecraft like Voyager explore the far reaches of space, scientists are interested in whether life might exist beyond Earth. Future missions may search for signs of life on distant moons, planets, or even in interstellar space. By studying the chemical composition of planets, moons, and the interstellar medium, we can gain insights into whether conditions for life exist elsewhere in the galaxy. In the far future, the search for extraterrestrial life could lead to the discovery of new forms of life. As we send more spacecraft into deep space, it's essential to consider the ethical implications of our actions. What responsibilities do we have when sending messages, like Voyager's golden records, into the cosmos? Could they potentially attract the attention of hostile extraterrestrial civilizations? Should we prioritize planetary protection, ensuring that our spacecraft don't contaminate other worlds? These are just some of the ethical questions that scientists and space agencies are grappling with as we push further into the unknown. In the distant future, humanity may look to asteroids and other celestial bodies for resources. The concept of space mining involves harvesting valuable materials like metals and water from asteroids. While Voyager wasn't designed for such missions, future spacecraft could be equipped to locate and extract resources that could support human colonies on other planets or sustain long-duration space missions. Space mining could be a game changer, enabling humanity to build spacecraft in space and venture even farther into the cosmos. The Voyager mission has taught scientists and engineers valuable lessons about the challenges of deep space exploration. From power management to data transmission, the success of Voyager has informed the design of future interstellar probes. For example, newer spacecraft may use more advanced propulsion systems like ion drives or nuclear-powered engines, allowing them to travel faster and farther than Voyager. Additionally, improved shielding and materials technology will help future spacecraft survive the harsh conditions of interstellar space. While spacecraft like Voyager physically travel through space, space telescopes like the Hubble Space Telescope and the James Webb Space Telescope allow us to observe distant galaxies, stars, and planets without leaving Earth. These telescopes have revolutionized our understanding of the universe, providing images and data from the farthest reaches of space. In the future, space-based observatories could be paired with interstellar probes to create a comprehensive picture of distant star systems, potentially discovering habitable exoplanets or new cosmic phenomena. As humanity continues to send more satellites and spacecraft into space, the issue of space debris becomes increasingly important. In Earth's orbit, space debris poses a significant threat to operational satellites and the International Space Station. While Voyager is far beyond any debris, future interstellar missions will need to consider the possibility of encountering micrometeoroids or other space junk. Developing strategies to avoid or mitigate the impact of space debris will be crucial for ensuring the safety of long-duration space missions. Voyager has lasted far longer than its original mission plan, but future spacecraft may be designed with even greater longevity in mind. Engineers are exploring ways to create spacecraft that can survive for thousands or even millions of years, either by using more durable materials or by designing systems that can repair themselves in space. These long-lasting spacecraft could continue exploring the universe long after human civilization has changed, leaving a legacy of exploration that endures for millennia. In recent years, private companies like SpaceX and Blue Origin have begun to play a significant role in space exploration. While NASA and other space agencies have traditionally led deep space missions, private companies are now developing technologies that could be used for interstellar exploration. In the future, private enterprises might collaborate with government agencies to send missions beyond the solar system, using commercial spacecraft to carry out scientific research, resource extraction, or even colonization efforts. Space weather, including solar flares and cosmic rays, can have a significant impact on spacecraft. For missions like Voyager, which travel far beyond the protective bubble of the Earth's magnetic field, exposure to space weather can cause damage to electronics and instruments. Engineers design spacecraft with shielding to protect against these hazards, but future missions will need even more robust systems as they venture deeper into interstellar space. Understanding and predicting space weather will be essential for the success of long-duration missions. One of the most significant mysteries in modern astrophysics is the nature of dark matter. an invisible substance that makes up most of the universe's mass. While Voyager wasn't designed to study dark matter, future interstellar missions could include instruments capable of detecting or studying its effects. By measuring gravitational influences or cosmic radiation in interstellar space, spacecraft could help unravel the mystery of dark matter, providing key insights into the fundamental structure of the universe. As humanity looks toward the future, the possibility of colonizing other planets or moons becomes increasingly realistic. Mars is often considered the most likely candidate for human settlement, but in the far future, we might look beyond our solar system. If spacecraft like Voyager can travel into interstellar space, it's conceivable that future missions could carry humans to distant star systems. The challenges of long-duration space travel, radiation exposure, and life support systems are significant, but breakthroughs in technology could one day make space colonization a reality. Although Voyager wasn't designed to discover exoplanets, its journey through space has coincided with one of the most exciting periods in astronomy, the discovery of thousands of planets outside our solar system. In the future, spacecraft similar to Voyager might be equipped with instruments specifically designed to detect and study exoplanets. By analyzing the atmospheres of these distant worlds, we could learn whether they have the potential to support life and how they compare to Earth. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.